In this video, I'm going to do question 7 from Edexcel A-Level Maths Paper 1 2018. So question 7, Paper 1 of June 2018, Edexcel A-Level Maths. My name is Sunil Tanna. I'm a tutor and author. My details are on the card there. You can find out more about me on the website. I'm available for one-to-one tuition either in person if you live locally, I live in Buckinghamshire, England, or online if you live further afield. Okay, let's look at the question now. The question says, show that this integral here is independent of k. In other words, it doesn't depend on the value of k. It's a little bit unusual if you look at it because you'll see the limits include k. Now, the other thing you might notice about the integral is you've got at the bottom 3x minus k, and of course if you differentiate that, that will give you 3, which is a constant. Now we have a similar but slightly different constant on the top. If we have a integral where the bottom differentiated gives the top, we can use the reverse chain rule. So by rewriting this integral slightly differently, we can set it up so that we can use the reverse chain rule. So what we will do is we'll rewrite this integral as being 3 over 3x minus k. But of course that would be different from 2 over 3x minus k, so we need to multiply by 2/3, and the limits stay the same. Now, this 2/3 is multiplying the whole integral, so we can actually move it outside of the integral. So this is the same as 2/3 of the integral written like this. Okay, now if we differentiate the bottom, we get the top. So in other words, this integral is natural log of the bottom, of course, times by 2/3 and with these limits. So it will be 2/3 natural log of 3x minus k between k and 3k. Now, if we substitute in 3k and k, we can actually evaluate the integral. So it will be 2/3 times, if we substitute in 3k, it will be 3 times 3k, or 9k, take away k, will be 8k, so natural log of 8k. And if we substitute in k, it will be 3 times k minus k, so 2k, natural log of 2k. Now the last thing we have to do to evaluate this integral is we use our laws of logs. Subtracting one natural log from another natural log is the same as a division inside the log. So it's 2/3 of natural log 8k over 2k. Of course the k's will cancel out, so it'll be 8 divided by 2, which is 4. So our final answer is 2/3 natural log 4. And of course that doesn't depend on the value of k. So we can say this is a constant that does not depend on k. And part A of the question is now complete. Okay, now we're going to look at the second part of the question, which I've put on a separate sheet. I've duplicated the question so you can still see the question while I'm working on the answer. And we have a slightly different integral here. The limits here are k and 2k. We have 2 over this brackets which are squared, 2x minus k squared. And what we want to do is show it's inversely proportional to k. So again, we're going to evaluate the integral. We won't be able to use the reverse chain rule here because if we differentiate the bottom, we're not going to get anything like the top. If, for example, you can see this would have something like 4x squared in it and some other terms if we squared out the bottom. If you differentiate that, that'll give you 8x, which we haven't got any x terms on the top. Okay, so what I would do when I'm looking at this kind of integral is I can probably kind of think about this integral. First of all, I can take the 2 out. So the integral is going to be 2k to 2k 1 over 2x minus k squared dx, which I could also write as 2 times k to the 2k 2x minus k to the minus 2 dx. And I can probably guess that the integral of this is going to look something like 2x minus k to the minus 1. Now that's not exactly right because it won't actually be that, but it'll be something almost like that. So let's try differentiating it. If this was right, it would go back to that. So let's try d by dx of this formula. Now if we differentiate this using the chain rule, we'd bring the minus 1 in front, we'd differentiate the inside, which would be 2, and we'd get 2x minus k to the minus 2. And if you look at this line, it's almost the same as this line, except for it's got this constant, which would come out to minus 2. So how could we make it exactly the same? We could multiply this by minus a half. So I'll put minus a half in there, which means if I put a minus a half in there. So now, once I've put the minus a half in here, this is the correct integral of this. So the integral will equal 2, because of that 2, times minus a half times 2x minus k to the minus 1 between k and 2k. Now, of course, this minus a half is a constant, so I can actually bring it outside of the integral even before I put the limits in. So this will now turn into minus 1 times 2x minus k to the minus 1 is the same as 1 over 2x minus k between 2k and k. Now, if I put the 2k in, I'll get minus 1 times 4k minus k, so 1 over 3k, minus, put the k in, it will be 1 over 2k minus k, so 1 over k. Now, if I multiply top and bottom of this by 3, I will have minus 1, 1 over 3k minus 3 over 3k, and simplifying this, I will get minus 2 on the top of this, yeah, but it's all times minus 1, so it'll be plus 2 over 3k, which is the same as 2/3 times 1 over k. Now, you hopefully remember that if something is proportional to k, the k would be on the top, and if it's inversely proportional, it's 1 over k would be the bottom. So you can see that this is the integral is proportional to 1 over k, or inversely proportional to k. Yep, and that's your answer.